Hello, welcome to Ekidel. My name is Justice Onwaka. I am your instructor. Today, we will be learning the understanding of foundation drawing. So, by the end of today's lesson, you will understand or you will learn how foundation reinforcement drawing is being drawn and how to detail a foundation drawing, and also to know the types of reinforcement required for a foundation drawing. So I would say that you should subscribe to this channel, Ekidel, and also share our videos to your friends. Okay, so let's get started for our today's lesson. Okay, today we will be learning the understanding of foundation drawing. Okay, before I get started, this is our foundation drawing. This drawing is showing a foundation footing um, and also the column sitting on the foundation footing. This foundation drawing is a part foundation drawing. As you can see right here, this yellow line here is the footing, foundation footing. Why? This magenta here is the column which sits on this footing. And this white line here is the reinforcement, and this also is the reinforcement on the other direction. While the red is the center line showing that this column is positioned at the center of this footing, and this is a section symbol cutting through this foundation, which if you cut through this foundation right now, this is what you will see. So this is section BB, which was cut through this drawing, this foundation plan drawing. Now, before you must draw foundation drawing, all foundation drawing must come from a foundation layout. So looking at this right now, this is a foundation layout. Now, this is a foundation layout of having different numbers of columns and column position, and also footing base. Like as you can see right here, this is a footing baseline. As you can see already called out as footing type 1. This FT1 means footing type 1. And this is a column showing C1, which means column type 1 or column 1. And this is the footing, which is sized 1.6 by 1.6 meters. And this is the formwork line where they will stay to board this foundation or do their reinforcement work on this footing base. And this is the wall line. This is the wall. So this is the brick wall which runs through the foundation. Now, this is exactly what they call a foundation layout. So all drawings, all foundation detail drawing must come from a foundation layout. So before you must start drawing your foundation detail drawing just like this, you must have a foundation layout. And that foundation layout will show the position of your column, and also will show the position of your footing, which is the foundation. And also it will also show other type of elements, just as these brick walls that is found on the foundation or the building. So this foundation layout is just like compressing the whole building, or standing at the top of a very high mansion looking at your building being compressed. So when this building is being elevated, imagining elevating this building using 3D, you see that these columns will be elevated just like this. just like this, having its reinforcement. It is this reinforcement that now withstand the load that is being transferred from the slab to the beam, and then to the column, and finally to the foundation, and then to the soil, to the surrounding soil strata. Now, but for our lesson for today is to show you, is to explain to you foundation detail drawing. So now that you know that all foundation detail drawing comes from a foundation layout. Now, this foundation layout has a typical foundation footing size of 1.6 by 1.6. But that is why you're seeing FT1, footing type 1, footing type 1, or the footing base has footing type 1. And also our columns here also is also the same. That is why you can see all the columns having the same column label C1, C1, and C1. So since they are the same, you will now have to pick out one of the footing base, which consists of the column, the formwork, and then bring it out for a proper detail. So after you have done your foundation detail properly, the next thing you do right now is to start bringing out each of the foundation detail. If you have different type of foundation footing types, so you begin to bring each of them out just like this. You begin to bring each of them out just like this and begin to show a proper detail of that footing base or footing type. So this is just what we just did right now here. So we brought this out right now. Now, just for it to look very visible, we scaled it by scale 1:25. So looking at this right now, this is what we have here. But on this place, this is only showing the layout. There is no reinforcement work showing on this. So that is why you will need to bring out your foundation footing and begin to do a proper detailing. So looking at this right now, as we have brought it out from here, now we now begin to show our detail, what is contained inside this footing base. Now inside this footing base, which is footing type 1, it has a 32 number doors. What does that mean? Since I told you before that our footing base are similar based on this foundation plan, on our foundation layout. Now if you count each of these right now, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 and so on. So if you count all the numbers of your typical footing type, then you cannot number it 30. You cannot put the number doors, and then you put the scale which you use in drawing your detailed drawing. Detailed drawing, there is no wrong you scaling your detailed drawing, because the main reason why you brought this out is to show the full detail of what is contained inside here. So you might not be able to scale this because this is a foundation layout which comprises of dimensions and others. So it is not good to scale a foundation layout or a building plan, but you can scale every other details, just as elevations in terms of architecture. They can scale their elevations drawing, but they can never scale their building plan, because that contains the actual dimensions which you need. And if at all you are meant to scale, which is not proper, you are meant to put the scale which you scaled that drawing with. Now, but for a detailed drawing, it is more common for people which do structural drawing to scale their detailed drawing, because you are trying to make everything visible for the engineer or for anyone reading or trying to understand your drawing. Now, this is a part foundation footing layout having its reinforcements. Now, the first thing you do when you have brought this out from your layout, the footing from your layout, the first thing you do is to offset your concrete cover. Now, a concrete cover of 75 was used for this case. Concrete cover of 75 was used for this case, but because we have scaled it up to 1 is to 25, so that is why. But if you scale it out here, there is this place is not scaled up. So if you scale it out here, you can see that it is scaled 1 is to 25. So you will have to offset your concrete cover first. When you offset your concrete cover first, then it is from that concrete cover you will now begin to draw your reinforcement. So looking at this right now, this is our footing base reinforcement on this direction, and this is also another footing base reinforcement on the other direction. A footing base reinforcement must have two types of reinforcement, one coming on the y direction and one going on the x direction. That is why it is usually called a mat reinforcement. So it must have a y direction reinforcement and an x direction reinforcement. Then it is from that reinforcement right now, once you have placed your reinforcement from the concrete cover edges, then you will now have to call out that reinforcement. This magenta color circle board that you're seeing here is a call out point. So you place this on that reinforcement, telling you that this reinforcement runs from this point where the concrete cover starts to this point where the next concrete cover is. So with this right now, anybody within your drawing, we know that with this arrow symbol here, you're trying to see that this reinforcement runs from this point to this point. Now, the same thing happens to this other direction. You also have to show how this other reinforcement is running. So you have to also offset your concrete cover and start from there, and then show your direction at which your reinforcement is going. So for this case, this reinforcement is going from this concrete cover to this concrete cover. And then once you have done that, you also place a bulb calling. This shows that it is pointing that this is the reinforcement that you are referring, and is running from here to the other direction. If this is removed, then your drawing does not make any other sense, because this arrow does not point out to any any reinforcement which is running. But with the help of this bulb, you will see that this bulb is telling you that this reinforcement is running from here to here. Now, the next thing right now you will do right now is to call out the numbers of that reinforcement and the spacing. Now, if this reinforcement is running from here to here, the next question someone reading your drawing will ask you, what is the spacing? How many number do we have on this? How many number of this reinforcement is going to run from this point to this point that you have said that this reinforcement is running? Now that is when you now have to throw out a line to call out the numbers of reinforcement and also the size of this reinforcement. Now, on this call out word here, this 9 simply means the number of reinforcement. How do you get the number of your reinforcement for a footing foundation or for a footing base? It is being gotten by the length of your footing, which in my own case here we have 1.6, which is 1600 millimeter by 1600 millimeter. This is actually a square footing. So how do you get your number of reinforcement? The number of reinforcement is gotten by the actual footing dimension, which is the actual footing dimension without any subtraction. So in my own case here, my actual footing reinforcement is 1.6. Now remember that we did an offset of our concrete cover because every reinforcement must not start at the edge. It must start from the from your concrete cover, just to avoid moisture from eating up the reinforcement so quick. So by the help of that concrete cover, you are trying to say that that concrete that will fill it on up this place will now prevent this reinforcement that is coming onto that is starting from here. Now the next thing right now you do, so how to get this number of reinforcement is your actual footing reinforcement minus your concrete cover. In my own case, we did 75 at this point and 75 on this side. So if I do 1600 millimeter minus 75 millimeter here and 75 millimeter here, so what I will get is this plus this is already 150. So my concrete cover left and right is 150 millimeter. So if you remove 1600 from 150 millimeter, what are you going to get? You will get 1450. So you now know that the space which our reinforcement is occupying on this footing base is just 1450 because we have already taken off our concrete cover left and right. Now with that 1450 right now, you will now divide it by the spacing. How do you get your spacing? This spacing of reinforcement, which is 200, right? You're seeing right now. In my own case, is 200. It's not a guesswork. This spacing of reinforcement is gotten from your design. When you have analyzed this building based on the load coming to the building, so after the load has been transferred from the slab to the beam, then from the beam to the column. Now the column will now transfer the load down to the foundation. So after you have done your foundation design, now it is at that point that the foundation analysis and design will now tell you the proper spacing that your foundation your foundation reinforcement is meant to be spaced to be able to withstand that load coming from the column. Now, this spacing is gotten directly from your design parameters. Now, also the size of your reinforcement, which is 16, is also gotten from your design data, from your design parameters. So in this case right now, this is just to explain to you, we are not doing design. You can check on our videos to also know how to design a residential building or any kind of building. But for this purpose, we are only showing you how to detail your foundation drawing. So now, this is actually a pad foundation. We have various types of foundation: raft foundation, strip foundation, pipe foundation, and also a pad foundation. So we are basically on a pad foundation. So right now, since we know now, knowing that the space that is occupied by your reinforcement for just this footing is 1450 millimeter. So that's what you now do: 1450 millimeter divided by the spacing, which gives us this, plus 1, which gives us this. Now this T right now simply means T, which is the type of the reinforcement, and this 16 here means the size of this reinforcement. So what I'm trying to tell the reader is that the size of this reinforcement is diameter 16. Now, what type of reinforcement? I'm saying that the type of reinforcement is T, and this T is a grade of our reinforcement. We have high yield steel and also we have a mine steel. So this is a high yield steel. So I'm trying to tell you that this reinforcement is a high yield steel of 16 diameter, having a number of 9. So having a number of 9. So if you're trying to offset, let me just show you what this number of 9 means. What I mean right now is that this reinforcement is here 1, and also we have it here 2, 3, then 4, 5, 6, 7, 8, and 9. So this is what I'm trying to tell my reader, that this reinforcement that is here is being spaced from here to here, 9 numbers with a spacing of 200. So with that now, so putting this right now, we have now called out that this reinforcement is starting from here and to here, which is having a spacing of 200 with a diameter of 16. Now, this O1 right here is a bar mark. This bar mark simply means, how do you call out your bar mark? Your bar mark in a bar mark must have the same diameter of bar. A bar mark must have the same diameter of bar, 1. A bar mark must have the same length of bar, and a bar mark must have the same shape. So once you have a reinforcement that have the same size of reinforcement, the same bending shape, and the same length, with that you can now group all those type of reinforcement as one bar mark. In this case, the reason why you're seeing these two having the same bar mark is because they have the same shape and the same length. Had it been this was not a square footing, maybe I have here 1600 millimeter and I have here 2000 millimeters. Now, I will not say this and this is a bar mark, because we have varying lengths. But in this case right now, they have the same length, so this is our bar mark. This is just at symbol showing that this number of 9 reinforcement at diameter 16 at bar mark 01 is being spaced at 200 millimeter center to center bottom top. Now, looking at this right now, you see that we have BT and BB. BB simply means bottom, and BT simply means bottom top. Both of them are both bottom reinforcement. Now, we are done with this place. Now, even with this, our reader can still be confused because he's saying, I don't understand what you mean by BT and BT. Even if we are going to put that on our notes, telling them that BT means bottom top and BB means bottom. But in a real sense, the person will still be confused. So that is why this is called a detailed drawing, to show more detail of what you mean by this BB and BT, and also showing this number of reinforcement, how they run and how they are being spaced. You will now go further to show a proper detailed drawing, which now takes us to this place. Now, first thing here, I'll explain the meaning of this BB and BT. This BB right now is in here, like I said to you before, means bottom. So this shows that this is the bottom. We have two bottom reinforcements here. Don't forget, we have the first bottom reinforcement and this one. One running on one direction and one running on the other direction. Now, one must carry each other before they can now intertwine. So with this right now, this one. So if we cut this section on this side, this section right now is trying to cut, like if let me just cut this right now. This section right now is trying to cut this reinforcement. So this section cuts this reinforcement. So when you look at this reinforcement on this side, you will see this one as if it's a circle because it has been cut into two. So you looking from this side, you'll be seeing this reinforcement as if it's a circle. Why this cutting line does not affect this line, this reinforcement. So this cutting line didn't cut through this reinforcement. So with this right now, this is what you see. This is the one that this cutting line affected. Sorry. This is the one that this cutting line affected because it is being cut through this place. So it cuts through this reinforcement. So this is the one showing this bulb. Now, because of that right now, you will now show, looking at this. Sorry, it's coming up. My system is about to hang. So looking at this right now, okay? Looking at this right now, this is our bottom top and this is our bottom. So you will have to show it here properly in your detail that this is your bottom, showing that this reinforcement is the one first and this is the 1 second. So this is our bottom reinforcement, and this is our bottom top reinforcement. So this simply means a bottom reinforcement on top of another bottom reinforcement. That shows that they are intertwined together. So now, drawing out this elevation, the reason why also you have to go more detailed, because the person right now reading your drawing does not know the thickness of this footing. So you will now have to show a section of this footing. So when you cut this section right now and elevate it, you will have to visualize how it will look on site. So elevating this right now, you will now say, okay, this footing has a thickness of 300. In my own case, it is 300 millimeter, that is the thickness. And also, you can see that for this reinforcement, we have 9 numbers of this system. So if you count this right now, you see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So you show that now your reader now is trying to understand you right now, because you have seen that, oh, this is 9 numbers of reinforcement. So the same thing that happens this way also happens to this reinforcement this way. And also your reader is trying to understand you too, that, okay, this footing is 1,600 millimeter, and also the same thing happens here. Now also you have now shown that this footing depth or this footing thickness is 300 millimeter. Not only that, you have also shown the reader that this column that is here is not a timber column, that this column has a reinforcement on inside it. So you have also shown the reader that this is a column reinforcement having its own spacing. In my next video, I will show you how I'll explain about column reinforcement, just as it is here. I will explain about this column reinforcement, but for today, this is just about part foundation reinforcement explanation. So I'll urge you to subscribe so that you won't miss my next video about that column reinforcement. Now it is also showing how this column reinforcement is sitting or being tied with the footing reinforcement. Also, this section detail also shows us the kind of material being placed before you can now place your foundation reinforcement. So this distance that you're seeing here, this distance is our concrete cover. So this is the concrete cover before the reinforcement, and this is also the concrete cover before the reinforcement on this side. Now, looking at this right now, this is your blinding, showing that before you must lay your reinforcement, you must have to prepare the surface of your foundation where the reinforcement is coming to sit. So to prepare that surface, you are trying to tell him that he must have a blinding of 100 millimeter thick with a projection of 100 millimeter. Then also, if I go forward now, I'm already entering the column, but I will not explain about this. Like I said before, I'll do video about the column. So this is basically for part foundation. So also you are also showing your reader that there is a soil on top of your footing foundation before you get to your finished ground level. Now you are also telling that there is a soil on top of your foundation. Now you also showing that the depth of that soil is 700. So you will tell your reader the depth of the soil is sitting on the foundation before you get to your finished ground level. Then also, you will also show the reader the depth of your foundation. Looking at this right now, this is our depth of foundation, which is 1000, because this depth of foundation comprises of the depth of your footing plus the depth of the soil sitting on the foundation. So sitting on the footing. So with this right now, that shows us that this foundation has a depth of 1 meter. Now, also, this FGL here simply means finished ground level. So this is the finished ground level of the site where this building is to be located. This is actually gotten from the architect. Now, also, there is also a paving block, which you also have to show your reader that there is a paving block just after the finished floor level. There is a paving block, but this is not necessarily important for a structural drawing. You will see more of this detail in the architectural drawing, but for this purpose, you will just have to show it to your reader. Then the next thing you have to show also is the final ground level, which is called the DPC. You will also have to show the top of concrete. This TOC means top of concrete, which is 300 millimeter at this point, and also the finished ground level. So you will also have to show your reader that that there is a floor level which also needs a reinforcement. But this reinforcement does not necessarily mean that it must be this size of reinforcement, which is 16 diameter. So this is just to reinforce the first slab or the first floor that you have, which on top of it you now begin to place your tiles. So this is just the floor that is being prepared to carry your floor finishes, just like tiles or carpets or any other floor finishes. So you are also telling your reader that this is that you also show the reader that the size of that floor is 200 in this case. So you also input the thickness of the floor slab and also the kind of reinforcement inside that floor slab. For this case, we have a reinforcement of BRC wire mesh. So this is the specification A393M plus A193 BRC wire mesh, top and bottom. So the load coming on this floor is very heavy. That is why it is being done top and bottom, just to avoid cracks or to avoid your tiles being cracked. And also, okay, so I think this is almost what we have for the foundation drawing. So I believe you have understand how to draw your foundation drawing. But then the next video I'll do is to show the column. So you cannot draw your foundation drawing alone without drawing your column also with it. So to show a proper detail, you will have to draw your foundation footing drawing in together with the column drawing. So watch out for our next video, subscribe so that you not miss our next video on column reinforcement drawings. So this is how to draw a pad foundation reinforcement detail for a foundation layout. So this is how we do it. Thank you and watch out for the next video. Love you.